Hey, what's going on, guys? Coming here. I'm happy to announce the beginning of the new live stream series where I'm gonna be trying to deobfuscate world's smallest chess program ever written in JavaScript, which is called Tiny Chess. It's written by Oscar Toledo for some JavaScript contest back in the day. And the smallest version that we have currently is this one. So like the size of the source code is more than impressive, and it's in 1023 bytes only. So here is the version that is available to play against. So it plays chess, believe it or not. Okay, and if we have a look at the source code, then here is the entire source code. So we'll start with this sort of a source code. I'll just grab it now and then just run it locally, and then we'll go for beautifying the code and try to figure out how it works. I don't say that I'm not prepared completely. I've been making a bit of research on this, so there is a bit of a preparation for this sort of a thing. But generally, at this particular moment, I can't be 100% sure that I will be able to deobfuscate the entire program. However, relying on my 5+ years experience in chess programming, and especially in building the minimalist chess program, so one of the examples I've been up with recently, so here is my very first chess program series on YouTube with a meaningful variable names and like the normal style, but also I have the minified version, which is not as small as Oscar Toledo's chess, but still it's quite pretty small. It's larger than the Micromax by Harm Gertner. It's much bigger than this Tiny Chess by Oscar Toledo. It's written in Python, but it doesn't really matter that much. And here I even tried to I was trying to my kind of like brand new theory on encoding chess rules into the chess pieces. I have a video on that. That's currently the trailer on chess programming channel. It might not be so by the time when you would be watching this, but anyway, so I just want to give you an idea that I have a bit of understanding of how these tiny little chess programs actually should work. So there are a set of fixed parameters like the board representation, piece encoding, and the only function that kind of literally takes the chess position as the input and outputs the best move so far, and then the game loop to do this until the median score is reached. So quite a few similarities, like the boundaries for the entire code. So there might be some things different, like how to initialize the data, like initially how to store the board, the pieces, how to store the directions, the move offsets for all the pieces and things like that. But generally the structure is similar, so that's the reason why I'm trying this. And before we start, just one little fact, yeah. So back in the day, like around 5 or 6 years ago, when I just got an idea to how cool it would be to learn to code in general, and I didn't know how to code at that back in the day, and how to create a chess program in particular. This Tiny Chess by Oscar Toledo was one of the first chess engines I was impressed by in my life. And as opposed to Stockfish having numerous files of the source code and things like that, I had this tiny little paragraph. When I saw this tiny little paragraph of the source code that makes the like almost fully functional chess, it lacks the castling and peasant square capturing, but that doesn't matter really that much. So even with this, even without that, it was a complete mystery and a true magic to me. And actually it took me really quite a bit of time to get to an idea of how on earth is this possible. And I had to implement several kind of like normal chess engines in order to understand all of this logic behind the optimization of the source code to make it as small as possible, basically. So that's quite a bit of a background. And I've been trying to deobfuscate this code through the years several times, and it didn't succeed because every time I had some lack of, I don't know, knowledge, understanding, like some maybe not the best practices, because it's hard to say what are the best practices if only, I believe, two men did this, like Oscar Toledo and Harmgert Müller. I don't know any other small, like tiny chess programs like this. So there are really not that many examples to learn from. But anyway, I've been studying Micromax by Harmgert Müller for years, and I think I took all I could take from there, basically. And I really hope that this, I don't know what number for this take to obfuscate this code. I hope that this take is going to be successful, and to make it even more interesting, I'm doing this completely live. So I'm sorry for this kind of a bit too long intro to this video, but anyway, just wanted to give you an idea what this tiny little piece of code means to me. So we'll see how far would I be able to go in order to deobfuscate this code and in order to understand how things works. So if you're interested, then without further ado, let's actually start. Okay. So I've created a repository to store all this work I'm gonna be doing. So here is the cloned folder, and yeah, so this here will have the original source. So let's call this tinychess.html, and let's open it with the text editor. So here, oops, not exactly what I meant to have. So here, literally the body and the script should be enough. Okay, we don't need anything else. Okay, copy and paste, save, and now let's run this locally. Yeah, so now it runs locally. Great, tinychess.html. Yeah, and yeah, here we go. Okay, so here we have the initial version, and I just want to grab this, so just copy, and so here eventually here would be like tinychess deobfuscated file, but this would be later on. But for now we'll go to tutorials. There would be several videos. I'm not sure how many would be there, but anyway, so here I just want to make part 1. Let's make it like this, and paste, and rename Deobfuscated like this. Okay, so here we go. All right, so this is all we need, right? Okay, so just checking out if the video is recording here. Okay, let's go full screen. And the very first and the most logical thing to consider, I don't really want the code to be a single line. I just want to add some indentation. So fortunately, there is an easy way of how one can do this using the browser. I'm not sure how this works in Firefox, but in Chrome, this is relatively simple. So if I just press Ctrl+P here and pick up my file, and just using this pretty print thing here, and now I just can grab the entire code and copy, maybe just Ctrl+C would be enough, and paste. Yeah, and now at very least I have a reasonable indentations here. Okay, yeah, great. So it should be working. So yeah, the source code has been updated and it should be working as before. Okay, great. So let's have a look what we got here. So the first thing that is catching my eyes and my attention is this part in particular. So most likely here we have setting the source square to nothing and put in a piece on the target square and clearing the source square and doing the opposite thing. So replace probably I'm not sure which one but when we take the move back, we need to, on the target square, we need to restore the captured piece, and on the source square, we need to place the piece that was on the target square before that. And this, and in between, we have this recursive call, which I think this should be the alpha beta pruning, the eninge max search with alpha beta pruning. So why the eninge max search? Because we have this minus. So we negate the score every recursive call, hence this assumption. And probably, I'm not sure regarding the arguments, but probably they are something like depth, alpha score, beta score, and site to move maybe. Maybe it stores site to move somewhere in separate. I can't say this at this moment. At this moment, I have no idea. Yeah. So yeah. By the way, if yes, probably it's worth mentioning. So there is a book by written by Oscar Toledo himself, where he explains all the things. I don't have that book. I didn't buy it. It costs a miserable price, around $10 apparently. I'm not sure. Yeah, here it is. And he promises to explain not only how this nano chess works, but also the basics regarding the chess programming as well. So this might be extremely interesting. Unfortunately, I never bought this book because I was always interested to figure out things on my own. But for those of you guys who has this book, this might be really fun to see the comparison of how a random guy from internet like Kumakikin, what he can reveal from this obfuscated source code, and if that would be compared with the content of the book, that would be interesting comparison. So how far would I be able to go having only this source code and my general understanding of how minimalist chess engines are working. Okay, so we have this I, and most likely, so this is my assumption. We're going to be checking out every single assumption and every single statement made. But I just want to give you an idea that at this particular point in this moment, it's really hard to say anything like 100% sure, because like it looks a little bit like a gibberish because the meaningless variable names can't tell you much. But I think that, well, bearing in mind this x, we just have this recursive call, so most likely this function x is the search. And by the way, well, I think that, just wondering if I just search for, x. If we just search for big X, so here as well. So, well, I think that I can just replace this by the search and replace all, and hopefully this should still be working. Okay, yeah, here we go. All right, so we got one thing obfuscated. So here we can say search position for a best move. Okay, and here is the initialization of this I array. So I assume that at very least it contains the board position, but bear in mind that we don't really seem to have move offsets, right? Then it's probably the move offsets has been stored using this trick initializations, has been stored here as well to this I array. So we can inspect this array, and if I just say I, and here we go. So 7 7, and this looks like black pieces, I believe, because of the board and the NS. This probably, well, we can, we would be like checking every single statement I'm making here, but for now this seems like black pieces, and this seems like the black pawns. Yeah, and by the way, you see, like here we have a 0, right? And here as well. So if you just update and just print this I, yeah, no, we don't have that 0. Okay, so probably if we manipulate this, that we can go for manually setting up the position. So I think that here 10 by 12 board representation is used, and here is the deal. Why? Because you see, like 1 2 3 4 5 6 7 8 9 10. So here is the chunk, okay, and then another one, and so on. So again, like how to check that. So we'll now assume, so yeah, let's have a look at the number 120. So here it stops, and yeah, and somewhere below, yeah, and these are probably the Y pieces. I think these are the Y pieces. I can't manipulate them right over in here, but anyway, so let's say if I take this array I at the index of 98 and set it to 11, then probably I would have a white knight here. So let's check that out. So what was it, 98? Yeah, 98. So let's take I indexed by the 98 and let's make it equal to 12. And I'm not sure, probably this W to update. Yeah, oh, it's a bishop. This doesn't matter really. But anyway, then we know exactly for sure that this is the matter of piece encoding and board and the board representation. So from now on, we can state the board representation and the piece encoding. But just to make it a bit more clear, and so I would be adding some additional functions just for debugging. So let's say that here. So here we have the original engine. Okay. Okay, so original engine. Yeah. And everything that goes here would be helper functions just for debug. Let's say, yeah, for debugging. Helper functions for debugging. Well, I hope it's error-free in terms of spelling. Okay, so let's start with print board array functions. So function print board, and well, I really hope, can I see the variable I from here? Now let's just say console log and I and update, and now I should be able to say print board print board is not defined. Yeah, this is a little bit strange. Oh, that's because I have a wrong file being loaded. Sorry guys, so I need to go to this one, or was it? Hold on, I'm just I feel a bit lost with my. So what's the file name? Oh, I'm doing this within the source file. Okay, so just a bit wrong place to okay, my bad. So just swap them for some reason. So open. So just want to place this one, Control X here, save, and this one here, save. Yeah, but the way I want to work with, yeah, it's too late to switch to 2. Yeah, I believe it's too late. Okay, let's skip on 4. But at least now we should have, yeah, now we have these helper functions, and now there should be the print board. Okay, and we do print the entire board array, but we don't need the entire board array. What we actually need here is just the first 120 elements. So I can say, so loop over board rows, and this would be for variable row equals to 0, row is less than 12, right? And row plus plus, and then the same for columns. So col is less than 10, and col like this. Yeah, I need to store a string somewhere. So here, board array string. So let's call it board string, like this. And here, so yeah, here just give all the commentary. So loop over board columns, or we can say rows are files, right? Files, and columns are board ranks, right? Rank 1, 2, 3, yeah, ranks. No, hold on a sec. Here we'll loop over the ranks, and here we'll loop over the files. Yeah, this is it. So initialize score. So here we want to convert file and rank to board square index. So we can say, let's say the variable square equals to row multiplied by 10, which is the width of the board, plus the column. And now whatever we have, so here we want to populate board string. So board string plus equals whatever we have at I indexed by the square, and I want to give space here, and here we want to add new line, so let's say go to next rank. So let's say not the go to, but print next rank, board string plus equals and the new line character. And eventually we want to print board string, board array, and just say console.log and our board string. So now if I just say print board, okay, perfect. So now we have, yeah, and this is what I've been assuming basically. So now we have, see, like it really looks like a chessboard now, right? So I'm just checking the mic. So we have the black pieces, I believe, yeah, and the white pieces down below. So this is 4 pawns, so on. So I don't know if it's worth of, yeah, we'll probably, so yeah, I'm just gonna be making some kind of proved statements in the commentaries within the source code. So let's say, so here we have the board representation. Oh my god, guys, I'm so representation. Sorry, I just needed to check the spelling. Yeah, seems to be okay. So yeah, we'll now grab this from here, but before that, yeah, also the piece encoding. We'll have the piece encoding here. Okay. Yeah, I'm just wondering, so what would be the better way of so okay, so let's say black rook and we have 5 and black knight we have 3. I'm gonna be checking this out, but for now it's almost, I'm 99% sure that this is true. So black bishop is 4, then 6-2. Yeah. Black queen 6, black king 2. Yeah, and now the white pieces, and yeah, also black pawn is 1, right? Yeah, here are the black pawns. Okay. Yeah, probably. So maybe it's be like this. Okay. So how it looks. Piece encoding. Yeah, it looks okay. Yeah, we just go for board representation here. All right, so here we go. So I just want to have the commentary blocks. Well, maybe. Okay. I just call it debug. Okay. All right. So yeah, engine. So here would be the code that we would be adding along the way. Okay, so I can change the layout later. So white pawn, and seems like 9, right? So white knight, and seems like 11. Okay, 11 white bishop. Is 12 white queen, no, white rook. Yeah, by the way, hold on a sec, why did I start with, yeah, let's start with black pawn, black knight, black bishop, black rook, queen. Yeah, now this makes more sense because we have we have the pawn and king and the knight are below 4, which so we can distinguish the leaper pieces from the slider pieces, just like in Micromax by Harmgren Miller. I'm not sure, but that's a very logical assumption to fake captures, or however he does the break from the loop along the attack ray for sliding pieces. I think that's the way. So now it makes sense to me for a list. Okay, so white pawn, white knight, white bishop, white rook. So it should be, yeah, 13. Queen 14, king 10. So white king is 14. no, y queen, and y king 10. And now it should be the same, so 10, then 11, yeah, 9, 10, 11 leaper pieces, and then starting from the bishop, 12, 13, 14, these are the slider pieces. Yeah, that makes perfect sense. Yeah, that makes perfect sense. Can we centralize this slide a little bit? Yeah, I think this makes sense. Yeah, and now the board array. Yeah, so another thing just for this debugging things. So I want to map piece codes to let's say to Unicode characters, because anyway, or just wondering, wait, well, he does use Unicode anyway. Yeah, but he does this in a very kind of like in a very smart way, so I can't even guess where exactly that is happening, to be honest. So yeah, let me just grab the Unicode values from my own project. Because anyway they are the same, even though he takes them from somewhere else, but I think so. To Unicode characters, so no, I'm not going to be using the dictionary. Just say pieces equals to, and now so 0 is absent, so for 0, I'm just wondering, can we use a string like this? I think we can. We should be able to. So here we have the dot, then black pawn. Which one to use? I think I should use this one, assuming that we have the light theme in the browser. So yeah, let's use this one. Okay. 1, then 2 is black king. Copy the black king. Then 3, the black knight. Then 4, black bishop. Black bishop. Then 5, rook. 6, queen. 5, rook. 6, queen. And I guess the same order for white pieces. So, or hold on a sec. Nope. No, not that fast. Not that fast. So 6, then 7 blank, 8 blank, and then starting from the next one, there should be a white pawn. Copy, paste, and then the same order. And if I did everything properly, it should match in the printboard function. We'll just be referencing these pieces. Yeah, then the knight. Yeah, so here order makes sense. So we have the leaper pieces here and here in first run, and then we have the slider pieces. That's a very natural way to distinguish between the slider and leaper pieces. Okay, and then the bishop, and then the rook, and then the queen, finally. Sorry. Okay. I think we don't need this anymore. So for an offboard, offboard is 7. 0, 1, 2, 3, 4, 5, 6, 7. So let's take X for offboard. Okay, so it should be printing X's for offboard. Then we can translate this back to like a white space. But first, so not the board square, but pieces indexed by whatever we have on the board. And now here, the same picture, like the same position should appear, but it doesn't for some reason, which is really strange. Oh, yeah, I think I just should call it print board. Oh, right, so it's already looks like something. Yeah, so here we have the position. Yeah, it seems to be okay. Yeah, and now can I make this bigger? Yeah. Okay, and now let's replace this with just an empty line. Okay, and let's print the board again. And we have our chessboard, which is absolutely fascinating. Okay, so what we can state from now on, by the way, just to give I just want to print it here in the board representation section. Just thinking what would be the better way of doing this. Yeah, probably let's give it a big X and print board. I just want to grab this. Yeah, and by the way, hold on a sec. So before, yeah, probably would it be better to, no, so here I just remain what it is, and it just, for just here I want to print the original values. Okay, and now I grab them and now place them here. And now it looks much better. All right, so maybe, yeah, just so. Okay. All right, so. Yeah, I'll probably use a bit longer, just like this. Okay. Or maybe yeah, I just probably go for this like separation. All right, so yeah, you know, I like it. It's necessary. The only thing I can mention as well, then the offboard value is by fact 7, which we can see here, and empty square is 0. So well, this should be true. Really hope so. This kind of should be true. All right, so we got the piece encoding, we got the offboard empty square, the board representation. All right, and what else? Yeah, save. Okay, and here pieces, and here we can say 10 by 12 array. Okay, so it's 120 elements. Well, that's a pretty standard board representation. Okay, so let's save and let's have a look again. So hope didn't break anything yet. Yeah, by the way, I'm just wondering. Yeah, this is probably does have a randomization. Okay, it's just probably like that. So printing the board. And yeah, and by the way, what's the interesting thing is that even when we make a move, here we have the position being updated properly, just to prove the fact that we've guessed the piece encoding and the board representation properly. Okay, so probably I can just, so here it's the GUI stuff. I think that I can just add, so one to print board every move. So for debugging, so print board, and now I guess that yeah, we have the initial position. Okay, yeah, it's probably printing the board even just every time I click, basically, because it fires like an on click event, but it doesn't matter. Still, just yeah, it's a bit of a duplication, but anyway, it's better like do it like this, so we can cancel, right? Yeah, but anyway, whatever position we have here in the GUI, we have exactly the same position in the console, which is pretty good by far. And yeah, I probably okay guys, I think that just in order to avoid having this, even though it's a kind of like a live stream, in order to avoid them lasting forever, I would probably stop here. And just a little bit of a teaser for the next part. That's something I've already I've been checking so far. Just to give you an idea, because my typefish shares exactly the same board representation, like 10 by 12 array. So like exactly the same board representation here. But I just want to have, yeah, here are the piece offsets. So like the piece offset for pawn, for knight, it's not all of them, it's only the positive offsets. For rook, let's say 10 1, or like then would it be like minus 10 minus 1 as well. So okay, just show you a better representation of it. So here is the complete set of offsets, bearing in mind the current board representation, the current board size. So here are the piece offsets for every piece type. I'm not sure, probably he might be, Oscar Toledo, the author of Tiny Chess, might be having a different implementation for pawns, I believe, but for the rest of pieces, this should be about the same. And just to give you an idea, what am I talking about? So if we just print this I, which stands for board array, it's not only board array, it literally incorporates tons of things, but say right over in here, not yet sure what this value stands for, but when I have a look at this values, this really seems like rook moves. Nope, hold on a sec. No, this might be, no, this might be more like a pawn move, because minus 11, minus 10, like capturing diagonally. So, well, it's all guessing at the moment, but, well, obviously, yeah, obviously later on we'll check this out in greater details. And also bear in mind the fact that initially we have this ASCII, ASCII characters to represent the pieces, and then we just subtract 64, and 64 is ASCII A minus 1. So just have a look at A and char code that. So we have the 65. So here we subtract 64, which is A char code at minus 1, and this makes perfect sense for the actual encodings that we've came up with here, right? But I guess that, I'm not sure, but I guess that this ASCII values might potentially be used to index this I array to reference the certain indices where the piece offset, where the move offsets for a certain piece type takes place. But that's just an assumption, and it really needs to be checked there out. So I'm gonna check that out, and if this is so, or if it's not so, anyway, in the next video we'll have a look how exactly and where in particular the piece move offsets has been stored. And apart from that, there also should be like piece weights, and probably he should encode the piece colors somehow to map the colors to the pieces, because otherwise it takes tons of code to say whether this is the white piece or a black piece if you just go for a raw comparison. So yeah, but maybe I'm wrong, I don't know. So we'll see this later on. But as up for this video, what we currently came up with, so we revealed the board representation type and the piece encoding. This is really great, and we've implemented the method to bring the board to the console. So from now on, every time we actually make a move, we can see the internal board being printed here. But a part of that, we also need the site to move, right? We don't need canceling and impedance square captures because they're not implemented, so just the site to move should be enough. And it's still about to be revealed of where exactly the site to move has been stored. Okay, so this is it from my side. Please let me know in the commentaries if you like this new format for like experimental live streams on Deobfuscating, the world's smallest chess program in existence, written in JavaScript. And anyway, I would be happy to read through those commentaries, and yeah, so if you have some thoughts, then I'm really interested to listen to them. And another important disclaimer. So if Oscar Toledo is gonna be watching this video, which I really doubt, but that would be an incredible honor for me. So, sir, I'm not about I don't know how to say this. So you're selling a book for money. I'm kind of like doing I'm kind of revealing this what you're selling for money. I'm revealing this for free, but it's not intended to to short your income or something. It's just a pure fans experiment, just to figure out if it is actually possible to come up with this implementation with your own brains, let's say, and experience in chess programming or not. So, but anyway, if dear Oscar Toledo, if you don't like this thing that I'm doing here, and then just let me know in the commentaries. I know you have the YouTube channel as well, and yeah, in that case I will delete this video. So I hope that makes sense. Okay guys, so this is it from my side, so thanks for watching. Until the next time, and take care.